Hello folks, we are going to talk about IP address classes. IP addresses are broken into classes. Common classes are class A, class B and class C. While there is a class D address space that is used for multicast and a class E address space is used for research. So we won't reference those in this video because we want to learn practical example. Class A address are decimal value 1 through 126. This would mean that the very first octet is going to have a binary value that begins with a 0. A class B address space is 128 to 191. This means that the first octet binary value is going to begin with 10. And the class C address space, the first octet decimal value is 192 and it means it will start with 110. The remainder bits can be set to pretty much anything. The only differentiator is in a class A address space where the 127 address is a reserved address and not counted as part of the class A address space. In a class A, the first octet indicates the network address. In a class B address space, the first two octet. In class A, the first octet. In class B, first two octet indicate the network ID. And in a class C address space, first three octet indicates the network ID. For example, in a class A address space with an IP address of 10.1.2.3, the first octet, which is the identifying value of 10, would be the network. In a class B address space with the address 172.17.2.3, 172.17 will be indicating the network ID. These two will be indicating network ID. And same for the class C, 209.165.202 would be network address. This leaves the last octet, which is 130 in the class C address spaces being the host address. In the class B address space, 2.3 would be the host. In a class A address space with our example, the 1.2.3 would be the host address. The formula to calculate the host number of hosts available is 2 to the n minus 2. 2 to the, I didn't write formula here, but the formula is 2 to the n minus 2, where the n is the number of bits in the host portion of the address. So applying the formula, we have around 1.116 million, not 100, only 16 million hosts when you have 24 bits remaining in the case of address A. Now with the class B, we do 2 the n minus 2, we end up with 65,000 hosts per network. And same for the C, we will end up with the 254 hosts per network. Now if you are wondering why we are subtracting these two addresses, it is because we have to account for two reserve addresses. The network address, which is the first, and the broadcast address, which is the last in each of the ranges. Class A, B and C addresses have default subnet mask. The default subnet mask for a class A address is a /8 or 255.0.0.0. A class B default mask would be 255.255.0.0 or represented as a /16. And a class C address space would be represented with the 255.255.255.0 default mask, or it could also be represented as A/24. So this is all from the address classes. So see you in the next lecture.